In a previous video, we made an alloy of potassium and sodium metals, and then showed what happens when you shoot it into water. A lot of you asked, why can we eat table salt or bananas, since those have sodium and potassium, without exploding? It isn't because it's a mixture of sodium and potassium metals. Sodium metal on its own explodes fine in water. And potassium lights on fire and then explodes. So what makes sodium chloride, table salt, so different? Well, let's make some chlorine and find out. A quick note before we begin, these chemicals are all very dangerous. Absolutely do not try this at home. This is an apparatus to make chlorine. Chlorine is a yellowish-green, highly corrosive gas. We do this by carefully adding hydrochloric acid to pool chlorine, liberating chlorine gas from the complex organic molecules within. To get this reaction started, we'll heat the sodium up until it's red hot, and then dip it into the chlorine gas. Immediately, the two elements react together, forming sodium chloride, table salt. So why do these two elements react together so strongly, but are perfectly stable in sodium chloride? To answer that, we'll need to go to the periodic table. As we go from left to right, each element has an additional proton and electron, and this wraps as we continue down the periodic table. Because of complicated quantum mechanics, certain amounts of electrons are more stable than others. For instance, the noble gases on the right, helium, neon, etc., have these perfect stable electron counts, the magic number being 8 in the outer shell, and so they're very stable. This also means that the alkali metals, like sodium, can lose an electron and become a positively charged ion that is stable like neon. And it means that the halogens, like chlorine, can gain an electron and become a negatively charged ion with the same electron configuration as argon, another noble gas. Once these elements have this stable outer shell, they become much less reactive. And this is what makes sodium chloride safe. It doesn't have the raw elements, sodium and chlorine, in it. It has the sodium ion and the chlorine ion, each of which are actually quite stable. What we have left in the flask is mostly just aerosolized table salt, along with a bit of ferric chloride. Chlorine is so corrosive that at the temperature of the reaction it also attacks the steel spoon in a similar fashion. This creates ferric chloride, which is yellow-brown, coloring the smoke. Now let's give it a try with the element potassium. Columns on the periodic table are called groups, and generally have fairly similar properties. In the alkali metals group, each element as you go down gets more and more reactive, and so potassium should be more exciting than sodium. While it is more reactive, it wasn't quite reactive enough to light on its own at room temperature. So, let's melt it with a blowtorch and then try again. The reaction proceeded forward notably faster and hotter, hot enough to actually crack the glass of this flask. The The flame was also a bit of a different color, as potassium burns with a purple flame, while sodium burns with a very bright and distinctive yellow flame. You've probably seen this distinctive yellow flame. Old streetlights that burned with a noticeable yellow hue are because they were sodium vapor lamps, now much less common since they've been replaced with LED bulbs that are much more efficient. Left in the remains of my broken flask is potassium chloride, along with a bit of the same ferric chloride. And now, for the moment you've all been waiting for, we'll try it with the liquid metal sodium-potassium alloy NaC. The NaC is so reactive it ignited immediately, even at room temperature. The NaC was stored in hexanes, which is similar to gasoline, and that burned with a thick black soot. Now, as we clean up this NaC with some water, I'd like to take this chance to really thank my patrons on Patreon. You make videos like this possible. If you'd like to become a patron, please look at the link in my description, and you can sign up, and I appreciate it a lot. Otherwise, if you like these videos, please like and subscribe. There'll be many more where they came from.